So as we start off today, we're going to notice that we're going to be talking about one thing, and our goal is I can explain how slope and y-intercept relate to real-world problems. So as we talk about real-world problems, one thing we need to understand is this. The graph here represents a few things. We notice on the y-axis, that is the axis that goes up and down, it shows miles, and it's going up in increments of 5. On the x-axis, however, it's moving in increments of 30, and it says minutes. So therefore, it looks as if there is something taking place by the minute. Well, just to give you an explanation of what is taking place, this would be as if two people ran something close to a marathon, which would be 25 miles. So at the beginning of the race, if you look at the graph, we can interpret that they both start out at 25. 25 would be your starting point. Well, sometimes they won't ask us what's the y-intercept, but on a real world problem, they'll say, well, what's the vertical intercept? What you would do is look at the vertical axis, which is the same as the y-axis. Therefore, what's the starting point for Jack? It looks like it's the same starting point for Will. That would be 25. So they both start out with 25 miles to go. Therefore, our vertical intercept would be 25 for both guys. Now, as we further look at this graph, we also notice that as Jack went along and ran the amount of 25 miles, by the time he gets down to where he has 0 miles, 180 minutes have passed. If you're looking at the graph, because it goes up in increments of 30 if you look, so it goes from 30 to 60, even though 60 is not written, and it goes from 90 to 120, and from 120 to 150, from 150 all the way to 180. So it took him 180 minutes to finish the 25 miles. However, Will, on the other hand, it only took him 120 minutes to finish the 25 miles. Well, if they ask you for either of our runners here, what is the rate of change? Something that you have to understand is that the rate of change is talking about how, over time, what is changing? How is the amount of miles changing over time? That's what we're talking about. So if we say miles, how they change over time, you could simply say this. The rate of change would be your change in miles over your change in minutes. Well, that sounds like something we've done before. Something that we talk about recently and that we've been doing for a little while now, and that is calculating the slope. So when we talk about the slope is the change in y over the change in x. Well, in this case, your miles represents the y and your minutes represents the x. Therefore, we can calculate the rate of change just by doing the slope. So I would look at Jack's line, or let's start out with Will since we're already writing in pink. So when I look at Will's line, Will starts out at 25. His first point would be the point 0.25. All right, and Will's second point would be over here at the bottom, up 120. Well, 120, and he did not go up on the y-axis, so it would be 120, 0. 120, comma, 0. That looks a little rough there. Yeah, it looks a little rough, but what it says is 120, 0. So, what we do next is you just take, like we do regularly with slope, and label these x1, y1, x2 under 120, and then put y2 under our 0 that's beside the 120. And from there, all you're going to do is set up the slope equation. Y2 minus y1 over x2 minus x1. From there, what we would do is go ahead and plug those numbers in. Well, our y2 is 0, so I'd say 0 minus 25 over x2, which is 120, minus 0. Let's go ahead and let's simplify that. Well, you're going to get negative 25 over 120. And that can reduce, that reduces to negative 5 over 24. And that is your answer. So that would mean that when you're looking at this graph, that Will is moving at 5 miles, or he's knocking 5 miles off the distance that he has to finish, 5 miles every 24 minutes. So he's moving at 5 miles per 24 minutes if his rate were a constant rate. So with that, we see how you can take the information from a real life situation and you can look into it, solve it, use the slope and the y-intercept to help you dictate what the information is saying and what's going on. So what we're going to do is in our next few assignments, we're going to be working on this and continue these concepts. If I wanted to, I could take the same situation for Jack and I could find the slope of his line, and that would tell me the rate of change, how he's moving, how his miles are changing, how much miles he has left, as well as the minutes go by. So, and if I were to do that, Jack's rate of change would be negative 5 over 36, which means he's moving at 5 miles. He's knocking 5 miles off his distance every 36 minutes. You can go ahead and try to solve that yourself and figure out. See if you get the same thing that I got. And why is it negative? Well, look at your line. Your line is moving in a downward motion, meaning that as time goes by, they have less miles to complete because they're constantly moving towards the finish line. So with that being said, this is talking about when we're dealing with real-world situations with the y-intercept and with the slope and how it relates. At this time, continue to your Schoology folder, and in there you will have some practice problems that you are to complete today. Thank you.